Hi, so I saw a question on graphs and functions in the professor questions area. Hoping, for at least from what I understand the question is, I'm hoping this answers it. It's about when you're given a non-linear function, the graph of a non-linear function, and certain points, how do you determine the output? Okay, well you'll notice that a lot of the functions that are written out in the text you're reading are written as, f of x equals, and then some expression with x's in it, say like, x squared. When you see this notation, the variable in the parentheses is your input variable, and then this entire thing, right, the f of x is how they usually say it, f of x is the output. Okay. So for instance, if I had this function here, and you'll see it says, it's got x squared, that would make it non-linear. A linear function will have your variable to the first power and no variables in denominators, and the variable to the first power will be the highest power. So maybe off to the side here, say I want you to find, what's f, what's the this function called f here, what's the value, say f of 2. All this is telling me to do is go to the function called f, right, which this is here, right, my f of x is x squared, and due to this input, right, so this, again, the thing inside the parentheses after the name of the function is the input, or the x coordinate of a point on my graph. Right, and I'll put this on a point on a graph in a second. And what you do is what the rule tells you to do. So this is telling me go to the rule for f, which is here, and apply the rule for f to the number 2. So what does this rule for f do here? It says take this input x and square it. Right, you do what's on the other side of the equal sign to the input. So I just go through the rule and replace x with 2. So the value of f at 2 will be 2 squared. Right? You see how 2 replaced x everywhere. Now 2 squared is 2 times 2, that is 4. So f of 2 is equal to 4. So again, this number in the parentheses is the input, or the x coordinate, and then what the whole thing is equal to. You see how f of 2 is 4 here? That 4 is the output, or if you're graphing, the y coordinate of the point I plot on the graph. So I'm going to make a rough sketch here of a xy coordinate plane. So you have, the horizontal axis, the x-axis. It's a number line, right? You got 0 in the middle, positives to the right, negatives to the left. The vertical axis perpendicular to that, the y-axis. And again, it's another number line with 0 here, positive y coordinates above, and negative going down. So when we state that f of 2 is equal to 4, what this means, it means that the point ordered pair, 2 for the x coordinate, comma, 4 for the y coordinate, is on the graph of the function that's named f. Alright, so I will plot that. So over here we got 2 is the x-coordinate, so I go to positive 2 on the x-axis, right? That'd be to the right 2 units from the middle there. And then positive 4 for the y-coordinate, so from the middle again I go up 4 for positive 4. Okay, and we're plotting, this point. So the only point on the coordinate plane here that's in line with both of these is this point right here. Okay. There's the ordered pair 2, 4. Again, all it means is input 2, output 4, input 2, and then this 4 is the value of f of 2, or f at 2, like I've written here. Alright, and then we can plot some other points. Right. There's f at 2. And then we can get other points that way, just like any other graph. You plug in different inputs, get different outputs, plot points, and hopefully after a while we see enough points to where we're seeing the shape of the graph. How about what's f at 1? Alright, so again here the input is 1. Alright, so that's my x-coordinate, 1. So there's 1 on the x-axis there. And this tells me to get the output, go to my rule for f and just replace x with 1. So f of 1 is 1 squared, and 1 times 1 is 1. Alright, so f of 1 is 1. So input 1, output 1. So the ordered pair 1, 1 would be on the graph. Input 1, output 1. So input 1 and then output 1, x-coordinate 1, y-coordinate 1. There you go. And then some people might stop here and make the mistake of drawing this as a line, saying, oh, there's 2 points, you can draw a line through these, so let's keep going. And notice that the power on x is not to the first power, it's squared, so that's a good indicator that the graph's not going to be a straight line. How about what's f at 0? Well, again, just now I'm at 0 on the x-axis, so right in the middle, 0 on the x, and I replace x with 0, so that's 0 squared. Well, 0 squared is still 0, so f of 0 is 0, so input 0, output 0, x-coordinate 0, y-coordinate 0. Right, so this whole line here tells me that 0, 0, what otherwise known as the origin, is on the graph. So this point right here where the axes cross each other, 0, 0 is on the graph. So you see it's not going to be a straight line. And I'll just do a few more. All right. The value of f at -1 would be, again, go to my rule for f, this thing up here. This is telling me now my input, my x-coordinate is -1. So I'll mark that on the x-axis. And then what it's equal to over on the other side of the equal sign, that'll give me the output. What is f at, the value of f at -1. So I just replace x with -1. So we have -1 squared. Now -1 squared, that's -1 times -1, +1 again. All right. So -1 input, +1 output. So the ordered pair, -1 for x, +1 for y, is on the graph. So I go -1 for x, +1 for y. This point is on the graph. And now you can clearly see that this is not going to be a straight line graph. All right, and I'll do one more. What's the value of this function at -2? All right, so this is, again, the thing in parentheses, the number in parentheses is the input, the x-coordinate. So I'm at -2, and then I plug that into the rule, right? It's x squared. Take the input and square it. It's -2 squared. Well, that's -2 times -2, that's +4. Okay, so that means this whole line here means that input -2, output -4, x coordinate -2, y coordinate +4 is another point on the graph of this function. And I'll do that here. -2x, +4y. It's this point here on the coordinate plane. And if you want, you don't have to keep plugging in integers. You can plug in, 1.5, half, 1 3/4, 2 1/8. It's just the integers are nice, end up with nice whole number results. And maybe after a while you'll see, these points seem to be forming this like U shape. And this goes, and I'll put a little arrow here indicating, because you'll have 3 squared is 9, 4 squared is 16, 5 squared is 25. I'll put a little arrow on the end here to indicate that it's going that way forever. And same thing over here. Okay, it would go this way and up forever as I move to the left. -3 9, -4 16, -5 25 would be on the graph. And you get this, U-shaped graph. I mean, this has a name. This is called a parabola, and this is specifically for these second degree or second power functions. All right, so maybe that's one way to answer your question. I hope that helped. Now, I think the other way to answer it would be, well, what if I'm given a graph, right? If you're given a graph of some nonlinear function and asked to find outputs and whatnot. All right, so say here's one more example here. So say there's the x-axis, y-axis, and let me draw just some random nonlinear function. All right, this is clearly not a line. All right, maybe it's going down forever on both directions, and I'll label some points. Say this point here has an x-coordinate of -3 and a y-coordinate of 4. Right, so that's the point -3, 4. In fact, I'll label that with the ordered pair, -3, 4. Say this point here is the ordered pair, 0 for x, right? You're in line with the middle of the x-axis. Let's go say that's under 4. Let's say that's 2. All right, again, I'm just making this up. All right. So that's the ordered pair 0, 2. And let's put one more point here. Let's say this point has x-coordinate of +4 and a y-coordinate of +5. All right, so x-coordinate 4, y-coordinate 5. That's that point right there. And they say, let's say the name of this function, instead of f, right? The last one was named f of x. Let's say this is called g. All right, this is function g. Or you could say this is the graph of y equals g of x, right, instead of f of x like in my previous example. So if I'm given a graph of some nonlinear function and they ask me, find this output, find, what's g of 0. What's g of 0? Well, I mentioned this before. What's inside the parentheses, that number, is the input or the x-coordinate. Let's put chord, right? That 0 is the x-coordinate of the point I'm looking at. And then g of 0, the whole thing, is equal to, and on the other side, that'll be the output or the y-coordinate of the point I'm looking at. So look at my graph. It's g. This is the graph of g, function g. This is telling me go to the point that has an x-coordinate in input of 0. Well, that's this point right here. This point's labeled with an x-coordinate of 0. Then the y-coordinate, that 2, that's what g of 0 is. So the answer to that question would be 2. The output when the input 0 and the output when the input is 0 is 2 in this graph. So I can do this a couple more times here. Same thing, I'm given the graph of some nonlinear function g. Find, say, g of 4. Okay. Now I look at my picture and I'm saying, hey, this is asking me, find the y-coordinate when the x-coordinate is 4. basically, right? What's g of 4? Is the y coordinate when the x coordinate or the input is 4. And looking at my picture, I have 4 comma 5, right? So here's x coordinate 4, and then the y coordinate is g of 4, right? So the answer to that one would be 5. And then one more based on my labeling here. Find, what would be g of negative 3? That would be 4, right? This is telling me my input is negative 3, so I'm going here, this point, and then g of negative 3 is the output. G of negative 3 is the y coordinate of that point, is the positive 4. So I hope that answered your question, as best I could based on what I understood when reading the question. Thank you.